Hello learner, welcome to the learning of computer networks and security. Let's continue with the module 3 concepts. Let's continue with the multicasting. We'll have here the multicasting concept. As we have already seen what is multicasting, it is something like send to a group. So the group of nodes what you have in the network, the group of nodes what you have in the network to the same group of nodes, like all the members are not participating in this multicasting, only few nodes among the network will participate in multicasting. So this messages whatever you are forwarding, it should reach only to the multicast group members, even though if the other nodes are receiving those information, the packets which is destined to this multicast group members, those other routers which receive the packets should discard that, right? So it is something like when you send a packet, you may send the packet to all the nodes, but only those group members which are participating in multicasting will accept the packets, rest other nodes will have to discard it. Okay, so that is how the multicasting takes place, and we will see now how these other routers will discard the packet. First of all, they should understand or they should be able to identify the receiving packets. That's how they will come to know that the packet is not destined to those, right? So then only they can discard the packet. So how this is made possible? So we have an approach called tunneling. I hope you have already seen this tunneling approach in IPv4 and IPv6, right? So the same tunneling approach is used over here. So it is something like you have here the multicast group members. Just look at this example. I have the first router, second router and the third router which are marked in red. All three are multicast routers. Rest all gray routers are non-multicasting routers. So whenever a source or whenever a particular router wants to send a packet, the packet should be forwarded to this other multicast 2 routers, and whereas the other gray routers what you can see here should be discarding that, right? So this is actually the physical topology, but logically when you think of multicasting group members, it looks actually like this. So here the packet should be transferred only among these routers. That is a logical topology, but practically physically this is the topology. Now here let's call these multicast group members as islands, multicast routers as islands, whereas this entire network we can call it as a C, right? So C of all unicast routers. So we call all these as unicast routers, whereas these red routers as islands or multicast routers. So here these, whenever a datagram is passed through multicast routers, that datagram should be encapsulated. What is the meaning of encapsulated? It is hiding the data within the packet. So here you can see a normal datagram is prepared. A normal datagram is prepared. When you call a normal datagram, it is nothing but a non-multicast datagram. Okay, so non-multicast datagram means this normal datagram will be sent to all the nodes in the network. Maybe it is multicast group member or non-multicast group member. So this normal datagram you prepare, and inside that normal datagram you encapsulate or you hide this multicast datagram. Now what is the intention of hiding this multicast datagram? It is something like, only those multicast routers should be actually opening up, unwrap. They should be able to unwrap this datagram and extract the multicast datagram out of it. So this multicast datagram is destined only to those multicast group members. So who should be able to extract it? Only this multicast router should be able to unwrap and extract this multicast datagram. But this normal datagram can be accessed by all the other unicast routers here in the network. So this normal datagram now consists of multicast datagram. So next, what do? We send through the tunnel. So what is the meaning of tunnel? It is nothing but the regular IP unicast thing. So regular IP unicast means what? So regularly, how you send the packets, same way these packets are sent through tunnel. Okay, so tunnel is nothing but you call this approach as tunnel. Actually, practically there is no tunnel available. Okay, so why do you call it as tunnel? See, it is something like the data that is flowing inside the tunnel. What is the data that is there inside the tunnel? It is a multicast datagram inside the tunnel, but outside, what is that tunnel thing here? Tunnel is nothing but the normal datagram. Okay, so tunnel is a normal datagram, so it is sent normally. And then now we, as we already know, this multicast routers, finally upon receiving this datagram, the multicast router will unencapsulate or unwrap the data to get this multicast datagram. So this is how actually the tunneling approach is used. We can just see here the concept of PIM. So what is PIM in multicasting? It is protocol independent multicast. As we already know here, this there is no protocol as such for multicasting, so you call it as protocol independent. So it is not dependent on any algorithm also as such, routing algorithm. Okay, so here only two different multicast distribution is scenarios are happening, two different ways of multicast distribution. So what are the two different ways? One is dense multicast distribution, and one more is sparse multicast distribution. So what is this dense multicast distribution? Dense, the meaning itself, the name itself says dense means the group of multicast. There is a huge collection of multicast routers, and they are all closely, tightly packed within each other, like closely packed means, too many multicast groups, multicast routers together. So you call this as very dense thing. So densely packed in close proximity. Close proximity means they are very close to each other, routers are very close to each other. And next, for this actually you require more of bandwidth. Why? Because there are more multicast members sharing the link, and definitely in order to deal with this dense multicast group, you have to you require more of bandwidth to transfer the packets. So one more is sparse multicast is actually the opposite of that. You have widely distributed group members and not too many multicast group members. And remember, these multicast routers are not closer to each other, they are very far from each other. Okay, but still they are all interconnected via intermediate other unicast routers, intermediate other non multicast group members. So they are widely dispersed, and for this actually you don't require much of bandwidth. Why? Because they are all widely separated, right? So yeah, that's what. So they are widely spread throughout, that is why you don't require more of bandwidth. So these two types of multicasting scenarios you have, one is dense and the other one is sparse. Next we can see the sparse dense thing. Okay, so just the differences between sparse and dense, or what are the consequences of this multicasting. So dense type of multicasting, so here you can see the group membership by routers assumed until routers explicitly prune. So what is the meaning of this? So we have actually the in multicast group, one router we can fix it. You can call that one router as a source router, or you can call that as one core point. So for that particular router or core point, other multicast group members should send first a join message, as we have already seen this concept. If at all a multicasting group has to be established, first one core point is selected, and then to that core point all the other routers which wants to join will send the join message. So initially all the routers in the network will be assumed as multicasting routers, all the routers. So why it is called like all the routers are multicasting routers? Why? Because this information, the join information will be passed through almost all the nodes in the network. It will be passed through almost all the nodes in the network, but finally whichever routers wants to keep themselves away from the multicasting group, those routers will send the prune message. So what is that prune message? Pruning is nothing but removing. So they are removing themselves from the multicasting group. So if at all say this router doesn't want to be in multicasting group, or this router doesn't want to be in multicasting group, then these two routers will send explicitly the pruning message, and that pruning message is nothing but they are removing themselves from the multicasting group. So you call that as pruning. Okay, next we have data driven construction. Data driven construction, that is on multicasting tree. So what is this data driven? That is actually by making use of RPF technique. So what is our RPF technique? So RPF is nothing but reverse path forwarding technique. So in reverse path forwarding, actually we have every node that is getting the information or getting the packet, and that node can accept the packet. That node can accept the packet only if the packet is arriving from the shortest path, okay, through the shortest path. Suppose here the router actually receives the packet. Suppose if this router receives the packet, from the above router, in that case this router will calculate the shortest path back to its source. So here source, let us take it as this router. So this router is receiving the packet from this above router, and once it receives, it will calculate the shortest path back to its source. Suppose if this is the shortest path, then definitely this router will accept that received packet. So you call that as RPF technique, reverse path forwarding technique, right? So here this construction of multicasting tree will be followed based on RPF technique only, and then bandwidth and non-group router processing profile. So this is nothing but bandwidth what is required is more, and then here since pruning also should happen. What is pruning? It is nothing but the non multicasting group router who doesn't want to be in this group will send a prune message to keep themselves away. So to do that also, again the processing of that will require more of bandwidth. So this is actually the complexity of this, or the drawback of this dense mode, we can say. Coming to the sparse mode, here we have actually no membership until routers explicitly join. So it is something like initially this in the sparse mode the multicasting group will be empty. So here all the okay, so I guess I just told the opposite of that. So in the first point of dense, actually as I already said, join message is not explicitly sent by any of the routers. Okay, so it is something like all the nodes in the tree will be considered as multicasting group members, and only those nodes which do not want to be in multicasting group, they themselves keep themselves away by sending prune message. So here all the nodes are explicitly, I mean they are assumed to be a part of multicasting group. That is where in the case of dense mode, so no join messages are sent as such. Okay, so whatever I said, that core point thing, that is actually applicable to sparse mode. I'm sorry for that. So here you have a sparse mode wherein you actually start with the center node. So in the center node, this center node is basically the one which is sitting there to accept all the join messages. So whichever nodes wants to join to the multicasting group, they will first send the join message. Okay, so once the join messages are accepted by core point, all these routers are joined, and you call that as a multicasting group. So that is how the sparse tree, multicasting tree is constructed. Whereas in dense, what do we have? All the nodes are accepted, assumed as a multicasting group member, but only those routers which do not want to be a part of that, they will send prune message. Okay, so that is the difference. And next we have receiver driven construction. So here we have center based approach. As I already said, one node you consider it as a center node, and to that center node actually the the link is attached, or you can say the join messages are sent, so via which the multicasting tree is constructed. And for this actually the bandwidth is not much required. Why? Because the non-group router processing also is not there, and then bandwidth is not very much required. Why? Because these nodes will be not closely located. These nodes are very far located, far away from each other, so bandwidth is not much required, like how we had in dense mode, right? I hope you got the differences between dense and sparse mode of multicasting. So in detail, I don't think we have to see this again. So this is the dense mode, wherein we have flood and prune technique. So here all are assumed as multicast group members initially. So here all the datagrams are flooded throughout the tree, maybe the routers, multicasting routers or non-multicasting routers, both will receive the packets. But finally, what is this pruning happening? Those routers which do not want to be a part, they will send the prune message, and then they keep themselves away from this multicasting tree. Okay, so here RPF technique is followed. So reverse path forwarding technique is followed for accepting the packet, that is shortest path calculation is done back to the source. Okay, so for every incoming datagram, RPF is a technique that is used, and here it is less complicated, or you can call it as less efficient downstream flood than DVRMP. So what is DVRMP? So we had multicasting routing protocol, distant vector multicasting routing protocol, which we had discussed in the previously. Routing algorithm was used. So when you compare to that, this dense mode is less efficient. Okay, so there next we have has protocol mechanism for router to detect it as a leaf node router. So here when do you come to know that it is the last node here? So last node here, so it is something like whenever you reach the last node in the network, and you call that last node in the tree structure, multicasting tree structure, the last node you call it as a leaf node, right? So that leaf node is the once you reach that, so router should be able to, or you can say one should be able to detect that it is the end of the tree, or it is the last node. So there is a mechanism for detecting that, and to say that it is the last node in the network. You can just see here an example for that to understand it in a better way, all the previous points what we had discussed. Okay, so we'll just take an example there. Okay, so first we will see the sparse mode here. So in sparse mode, like how we know, we know it is a center based mode. So in center based approach, we take one particular node as a center, and here I guess it is R6 is a center node, and R6 center node, to which join messages are sent by R3, R4, and yeah, R4 sorry, R1 wants to join via R4, and it will reach R6. R3 also wants to join, R4 also wants to join. So these are the three nodes there which are part of this multicasting. You can see here this particular router, you call it as Renzevis point. Okay, R6, and now intermediate routers update state information, and then they join. Intermediate routers are nothing but these routers R2, R5 and R7. They are all helping out these routers to join. That means they are just forwarding those they are forwarding this information, join message, to the next router on the path. Okay, so that forwarding, whenever that forwarding is happening, that state is actually updated in its routing table. So here once this join message is sent, now it can switch to the source specific tree. Source specific tree means it is a kind of logical point wherein R6 is considered as a source. You can call this R6 as a source, or else you can consider any one of this R1, R4, R6 or R3. Any one of these routers can be acting as a source now, and once any one router becomes a source, you can now switch on to the source specific tree. Okay, so source specific tree. So because of this, now performance is also increased. Yeah, so earlier what we were just saying, there is entire in the dense mode, actually all the nodes are considered as a multicasting group members, like I already said, all, but only those one who send the prune message, they will be out of that, right? So suppose here R7 will send prune message, R5 will send prune message, R2 also will send prune message. I am speaking about which mode? Not sparse mode, remember I am speaking about dense mode. Okay, in dense mode, in dense mode, you can see R2, R5 and R7 will send the prune message, and they will be just away from that. And then whenever this flooding takes place there, flooding is packets will be sent to all the nodes in the tree. So there, once the packet reaches this last node, that is leaf node, there should be a mechanism to detect that leaf node, right? So here who will be knowing that information that it is a leaf node? See, R7 itself should know that there are no more outgoing links, right? When there are no more outgoing links, it means that that particular node is a leaf node. Similarly, when it comes to R6, actually there is see, incoming node and one outgoing node, you can say. Again, see, every node has two links, one incoming and one outgoing, right? So here, when it reaches to the last node in the network, if there is no outgoing link over there, you can consider that as a leaf node, right? So that is how a leaf node can be detected in the case of dense mode. Okay, we have the sparse mode, that is for example, when we had in dense mode, we actually didn't have this RP point, RP or something. We didn't have core based method, right? So in dense method, we used to flood the packets or datagrams to all the routers there, right? See, R1 will forward the packets to R2, R4, then then thereon, I mean, then it will flood to R3, then R6, then with the help of R4 it will flood to R5, R5 will flood to R7. So you can just see here, unnecessary at R2 and R5 flooding used to take place. And finally, see here in R7, when it reaches leaf node R7, even then this R7 is not a part of multicasting tree. Here R5 will take some time to send the packets to R7. So it is all waste of time. So processing of packets, actually here it takes a lot of time, waste of bandwidth here, right? So that was in the case of dense mode. But when it comes to sparse mode, here we are following the method of uh, here RP. So RP is nothing but the center based approach. It is a core point center router, wherein join message is first sent in sparse mode, and only those routers which wants to join will join into the multicast routing. And then in dense mode, we had pruning technique only there. Like here we don't have any pruning technique. Why? Because only through join messages routers will join the RP, and then the downstreaming takes place. So downstreaming is nothing but send the packets to only those routers which are part of multicast group. So here join message is actually up streaming. So join message is upstreaming, in the sense it is just sending the message to the core point, right? So you call it as upstreaming. So here finally, once the packet once the tree is constructed, or once the packets are getting exchanged, if there are no more receivers over there, if there are no more receivers or no more downstreaming is taking place, in that case you can just stop here. So core point will stop will send stop message, or this RP will just send the stop message if there are no attached receivers. That means if there are no receivers, no multicast routing receivers, in that case core point will somehow come to know that whenever it is sending the packets, it will just if there are no receivers or listeners there, it will send a stop message. That is the meaning of stopping this multicasting thing. Okay, so you start multicasting through join message, and you can stop the multicasting through stop message. So that is how this multicasting takes place in two modes, dense mode and sparse mode. And finally, we can just see that all we have just seen the routing algorithms, in that we have seen distant vector, link state, hierarchical routing, and then we moved on to the protocols, intra AS routing protocol, inter AS routing protocol. So two intra AS routing protocol we have seen, RIP and OSPF, and finally inter AS routing protocol, BGP we had seen, border gateway protocol, and finally we came to broadcasting routing technique, and finally we winded up with the multicast routing technique. So this actually completes your network layer concept. Thank you.